Hello, I'm Joe French, coming to you from my classroom in Mount Pleasant, Utah, and this is topic 2.2 in the AP Calculus curriculum, defining the derivative of a function and using derivative notation. And these are some examples of the concepts that are covered with this topic. So let's look at our first example. First of all, we're given a graph, and shown here is the graph of a differentiable function f, along with the line tangent to the graph at x equals 2. So here's x equals 2. Here is the line tangent to the graph at x equals 2, right there. And we want to know the value of f prime of 2. F prime of 2 is the derivative of the function when x equals 2, according to our notation, which, as we know, the derivative is also equal to the slope of the tangent line, as well as the instantaneous rate of change. So given the graph, we have the tangent line, so we can calculate the slope. And if we look at our rise over run, here's a rise of 3, or a run of 3 going from 2 to 5. And in that same time, we go up 3. So my rise over run for my tangent line will give me my instantaneous rate of change for a line, or my derivative. So my derivative at 2, f prime of 2, is 1. Let's look at another example. Here they give an equation for the tangent line, the line tangent to the graph of the differentiable function f at x equals 5. So they're giving us the line tangent to the graph at x equals 5. What additional information can be determined from the given information? Well, we know that the tangent line slope is equivalent, is the same as the derivative at that point. So we know this tangent line appears at x equals 5, so my derivative, f prime of 5, is the same as the slope of my tangent line, which we can pull from the equation of the line. So my derivative is 3. Now, where is this tangent line slope occurring? It's occurring at the value where x equals 5. So we know that the point of tangency has a value of x equals 5, and if we plug 5 into the tangent line equation, we get 3 times 5 minus 4, 15 minus 4 is 11. So the point of tangency, which occurs both on the tangent line and on the curve, is 5, 11. So we know that the point is 5, 11, and we know that the derivative at x equals 5 is equal to 3. Let's check out one more example. Here we have a differentiable function with f of 0 equals 4. So that's some important information. The graph of f prime. So this isn't a graph of the function, it's a graph of the derivative of the function. The different values of the slope of the tangent line on whatever function they actually gave us. We want to know the equation for the tangent line at x equals 0. So the equation for a line, we like to use the point slope formula for the equation for a line, x minus x1, x minus x1. And they give us our values for x1 and y1 right here, 0, 4. So x1 is 0, y1 is 4. And then we need the slope. The slope is the derivative and we want the derivative value when x is 0. So we go back to our graph and we look here. When x is equal to 0, f prime, this is a graph of f prime, remember, is equal to 1/2. See how this is 2, so this is 1. So our slope is 1/2, which means our equation for our tangent line is y minus 4 equals 1/2 x minus 0. Now remember, if you're answering a question like this on the pre-response, you can stop right here and you will receive full credit. However, on a multiple choice, you may be asked to simplify y equals mx plus b. Okay, those are our examples for section 2.2.